Hello, my honors chemistry students. Okay, so today we're talking about significant figures. Um, and something that I want to preface. So first, ask lots of questions, or when you get an opportunity to talk with me, watch the video again if you need to, because this is something we're going to be using for the rest of the year. We're going to apply this to our calculations from here on out. Second thing, this is definitely an honors topic. So when you are watching the other videos that I'm putting out that are both for honors and Gen Chem, I'm not going to be using significant figures, but the expectation is that you will. But of course, in our assignments and when we're talking in class and when I'm working with you in class, I'll be using them then, okay? So, significant figures. First, and what should already have filled in, is we've already talked about accuracy and precision, okay? And we've talked about how to be precise in a measurement. And so when we look at measurements, what we're doing is through the calibration marks, we're recognizing all of our certain digits, and then we make one estimation in between the smallest set of calibration marks, and that is our uncertain digit. So like for this object here, we have 5.23 centimeters, okay? And all of those digits are significant figures. This one is an estimation. The last digit always will be, but we consider all of those to be significant. Okay? Just like how it would be unrealistic for us to say that this measurement based on this with this tool is 5.23498, right, centimeters. That is incorrectly precise. This tool is not capable of giving us those digits to that kind of precision. Some tools are, this one is not. Okay. Now, how can you know which digits are significant and which ones are not if you don't have the tool in front of you? Because often in the class, I'll give you numbers like 8 times by 10 to the third meters per second. Okay, and what you need to be able to recognize is, of that number, how many sig figs do we have there? So it's important that during our measurements and during our calculations that we follow those significant figures, sig figs, really closely so that we don't lose the precision, the accurate precision of those measurements as we move through our calculations. Okay? So here are the rules for recognizing significant figures and numbers. The first rule is that non-zero numbers are always significant. So if I have 582 grams, then I have 1, 2, 3 significant figures because they're all non-zero. Now, zeros are a little bit different. Zeros that are leading, those ones are never significant. So our example here, all these zeros that came before the non-zero number, those are not significant. I want to point out, it doesn't matter which side of the decimal they're on, okay? Because we could have 0.000.00125, and all of those zeros are not significant. So our final answer, we have 1, 2, 3 significant figures here. Trapped zeros are different though. Zeros that are trapped between non-zero digits are always significant. Okay? So we have this example down here. Those zeros are significant. So our total number of sig figs is 1, 2, 3, 4, 5 significant figures. Or if we have 502 milliliters, that would be 3 significant figures. Now trailing zeros are significant when there's a decimal place. But if there's not a decimal place, then they are not significant. So here we have 20.00. Because there is that decimal, all of these trailing are significant. So we have 4 sig figs here. Okay. Notice, it doesn't matter which side of the decimal place we're on again. As long as they are trailing and there is a decimal point, then they are significant. Same here. They're on both sides of that decimal point, these trailing zeros, but all of them are significant because the decimal is included. So we have 5 sig figs here. And so that was a precise number, right? Because the last number is our estimated one, and so we're certain of everything else. Okay, 50, this trailing zero is significant because again, we have our decimal point. So we have 2 sig figs. But this 500 here, there's no decimal. So those trailing zeros are not significant due to the lack of decimal place. And so we have 1 significant figure there. So that's not a precise answer at all. Okay, so with this in mind, 72.3 grams has 3 significant figures because Rule 1 tells us that non-zero numbers are always significant. 6.20 has 3 significant figures because Rule 2 tells us that all trailing zeros, and I want to say it's not, let's get rid of trailing zeros, not to the right. I mean, it is in this situation to the right of the decimal, but it doesn't matter in general. Trailing zeros that contain numbers with trailing zeros that contain a decimal are significant. Okay. Now here we have 60.5. Well, that's 3 as well because all trapped zeros are significant. Here we have 3 sig figs because leading zeros are never significant. And then here we have 3 sig figs again because trailing zeros without decimal are not significant. All right, doing awesome. Let's keep going. Okay, give this a go. Try it out. Determine the number of sig figs. So hit pause, try that, come back and see how you did. 4 sig figs, 7 sig figs, 5 sig figs, and 3 sig figs. Let's talk through these last 2. Now, when we have numbers in scientific notation, our coefficient here, that's significant, but this times 10 to whatever power, those are not significant digits. They still exist. We still keep them there in our calculations, but they don't come into play as far as significant figures go. And so that's why we have 1, 2, 3, 4, 5 sig figs. Those trailing do count as significant because there is a decimal point. Okay. Now here we don't have a decimal point. This zero's trapped, so those 3 are significant, but the last 3 are not because of the lack of a decimal place. Okay, we have to always be watching and taking into consideration sig figs when it comes to calculations. Okay, so let's talk about when we add and subtract first. When we add and subtract, the numbers that are contained within that, that expression, the numbers that are contained within that expression, the final answer can only have the same amount of digits after the decimal place as the component that has the least digits after the decimal place, not sig figs for adding and subtracting. So if I take 2.24, I add that to 3.4, and I add that to 5.231, well, my calculator tells me it's 10.871. This component had 2 digits after the decimal place. This one had 1, and that one had 3. Our answer can only have the same amount of digits after the decimal place as the component with the least. So we can only have 1 sig fig. So 1 digit after the decimal place. So I'd have 10.8, but notice the digit after it, 7, that's 5 or greater, so it's going to make that estimated 8 round up. So my final answer there would be 10.9. Now, when I subtract, same rule. We have 1 digit after the decimal place, we have 2 digits after the decimal place. So our answer can only have 1 digit after the decimal place. Now the 4 after that 1 is less than 5, and so it doesn't cause the 1 to round up. So our final answer is 7.1 centimeters. Okay, so when we add and subtract, it's the least amount of digits after the decimal place. But when we multiply and divide, it's the least amount of sig figs. So here, I'm taking 12.34 and I'm multiplying it by 1.6. So we have 4 sig figs and 2 sig figs. And the number that my calculator gives me is this big, long, overly precise number. These values are not capable of producing a number this precise. These measurements are not capable of producing a number this precise. Okay, and so our final answer can only have 2 sig figs because the component with the least sig figs is 2. And so I'd take this 19, and that's my 2 sig figs. The 7 after the 19 is 5 or greater, so it's going to make this round up to 20. Okay, you have to include that decimal. See, if we had 20 without the decimal, we'd only have 1 sig fig, but when we add the decimal, now we have 2. Same with division, least amount of sig figs. So we got 3 sig figs, 3 sig figs. Okay, so that's good. So our final answer, that's supposed to be a decimal. So get rid of that division, it's supposed to be a decimal. So that final answer can only have 3 sig figs. So we're going to take the 8 and the 9 and the 2, and the digit after that is 0, so it's not going to round that 2 up. Okay, so leading doesn't count, right? It doesn't count as significant. Look at my units. Remember, units also multiply and divide. So when I add and subtract values, they have to have the same units. But when I multiply and divide, they do not have to have the same units, and they also multiply and divide. So since I took meters divided by seconds, my final answer is meters divided by seconds, or meters per second. Okay, so in our next video on this, I'm just going to be working through some of these practice problems, okay? And then that will finish up talking through significant figures.